Geo Trig Honors, Lesson 8.5, Simple and Damped Harmonic Motion. So, a lot of writing here. Harmonic motion is anything that bounces back and forth or anything that cycles. We're going to talk a lot about a mass spring system where literally we would take a spring, hang it from the ceiling, and put a weight on the bottom. We call it a mass. It's a little more precise in physics. So then you pull it down gently and you let it go and it bounces up and down. And it just goes. A lot of things that we've talked about before that are also sinusoidal are sunsets, tides, weather. So this is a good way to model them. But in this one, we're keeping it simple. There's not going to be a phase shift. We're just going to pick where it starts, either at the center line or at the highest or lowest point. And then you can make it a negative cosine, a sine, or regular cosine, whatever you want. So we call the system oscillating when it's bouncing back and forth. I call it cycling a lot. I don't think I'm very consistent with my language here, so I apologize. But you've seen it all before. This is just basic trig. And all we're doing here is giving you an application. It shows up surprisingly often. So what's the amplitude, which I was supposed to do after the fact, but A is amplitude. And hopefully you remember that that's wrong. I'm supposed to go absolute value of A. I'm not getting into that in this one. D is actually the distance the mass moves. And the period is, as always, 2 pi over omega. I'm supposed to write a little scripty W, and I usually do, but not always. We'll also talk about frequency. Frequency is just a kind of funky F. It's 1 over the period. Now, I've drawn period there. I've also seen it drawn with a little curve like a tau. I'm just going with a T because that's what I think it is. Yeah, that's the same thing. I guess I should put this over here. I don't know who wrote these notes. Oh, wait, that's right. It was me. Now let's cut that because it's not working out. So frequency is 1 over T. Frequency is reciprocal of period. And the unit, frequency unit is hertz, which just means cycles, oscillations. And I write cycles because it's a lot easier to spell than oscillations per second. I will always go to seconds. You can do it in minutes and just call it cycles per minute. It's not a big deal. But hertz is what cool engineers say, and I want to get in with the cool engineer people. So let's model. Object's attached, and it's pulled 5 inches down from its resting position. I love graphing these. 1 cycle takes 3 seconds. So off it goes. That's really horrible looking. Probably something like that. Who cares? So write a model. The distance is, well, it's -5 because it starts at the bottom. It's a cosine graph. And there's something times t. So the only math we have to do is say 2 pi over omega equals 3. Tiny bit of math there. Omega equals 2 pi over 3. And that's what goes inside. Now, this is a bit of a problem for a lot of people because we've been doing some really, really hard trig. Some seriously challenging math. And this is easier. So yeah, enjoy it. It's easier. Don't get all crabby. Don't whine and complain. Just deal with it. Now we do it backwards. Hey, here you go. Describe the motion of the object. All right, well, this one actually starts in the middle, and it must have already been in motion. So I'll say it starts in the middle and goes up. Now notice I said we're modeling anything, but we're always going to talk about a mass spring system. Well, we have to, otherwise I can't say what direction it goes or what's going on. Maximum displacement is 10. So that's your center line. And that's 10. That's -10. What is the period? 2 pi over 5 is the period. Gonna make that a capital T. And the frequency is 5 over 2 pi hertz. That assumes the period is in seconds. Sure, why not? I didn't say anything, but that's fine. I should have, but I'm lazy. So there it is. Now, in a real system, things are almost always damped, meaning that the cycles slowly but surely, sometimes very quickly, let's try and draw this a little more obnoxiously, start to fade, and they start to get closer and closer to zero. Technically speaking, they never get there, but when they get out to infinity, they get there. I had a kid run a physics project once when I was a student who had a harmonic system, and he was being clocked on how long it was going to take. So I said, yeah, that's a little challenging. We're going to have to multiply by infinity. So we get this big, huge, ugly formula, which you'll never see again after you do some problems here. And amplitude, again, is A. B is the damping factor. And I believe M is the mass. So they put this in here, and the mass has got to be in a given units. So we're going to go with grams, but we're not going to worry about it too much. Off you go, write the function and graph with a calculator. What's the displacement after one cycle? Well, you need to blast it out in a calculator. I am not going to do it in my own calculator, so you won't hear me take forever clicking off to the side, but I will blast this out based on what I already know. So we get d of t equals 20. It doesn't say if it's pulled 20 from rest then released. So this really should be negative 20 cosine. Not sure why it's not. Yeah, I'm going to leave it positive. Let's say it's pulled up. So that would make it positive. Who cares? E to the negative bt, negative 0.8 t over the mass, which in this case is 20. Don't simplify, just leave it be. Cosine, and life gets ugly. Wait a minute. I don't know what that info is. So again, tiny bit of math to do. T equals 4 seconds, which equals 2 pi, excuse me, over omega. Omega equals pi over 2. So that goes in here, and we'll square it. Minus 0.8 squared, which is 0.64, over 4 times 10 squared, which is 400. This is actually probably the most important thing, is that the t goes outside. Blast that into your calculator. Yeah, it's a pain. Yeah, it takes forever. Yeah, if your eyesight's going, it's definitely going to be hard. And check it out. After one cycle, you should say, well, it was at 20. After one cycle, and I put it in my calculator and went to table. It's now at 17.05 centimeters. Started off at 20, and now it's slowly but surely getting less and less and less. That's damped. So this is just an application of Trig. You don't have to worry about it too much. That is it. Maybe one of my last videos for a while, so enjoy. And as always, happy mathing.